So far we have discussed about what is Gen AI. Now let's move into transformers. So when we discuss generative AI, the trick behind these generative AI are these transformer architecture. Now let's look into the history of artificial intelligence. So now let's look into the use cases for AI. So when we discuss AI, we have two major fields. First field is natural language processing. Second field is computer vision. So in general terms, natural language processing means AI softwares dealing with text. Computer vision means AI softwares dealing with photos, with images. They can be videos, images, anything. So when you discuss artificial intelligence, two major use cases: natural language processing, that is dealing with text; computer vision, that is dealing with photos. Now when we discuss the second term here, computer vision, so far computer vision models were only good for discriminating between cat and dog, apple and banana. It was able to identify how an apple looks, how a banana looks. It was able to identify how a cat looks, how a dog looks. Similarly, when we discuss about natural language processing, the AI models were able to understand the sentiments behind the sentence. Is it positive? Is it negative? It is a good comment or a bad comment. Similarly, identifying important entities inside a sentence like company names, currency denominations, all these things. So general AI that we discussed, the one that we have been using, the one that we have been using so far, it for natural language processing or computer vision, it was just for discriminating between two objects, or it was identifying what is that sentence all about. And then with few hard-coded rules, an algorithm was able to give us responses. Remember the chatbots that we have been using so far. We can only give fixed questions. Let's say we are on a bank chatbot. This chatbot will just respond to fixed questions. What is my balance? What is my account? When is my account statement being generated? It is going to respond to only fixed questions. However, these Gen AI models, they are going to be conversational. These Gen AI models are going to be conversational. That means it is going to communicate with you. Instead of just giving you facts and policies whenever a question is being asked, it will be putting that question in a nice way that you are going to understand it and you can respond back to it. So to create these models, research was undergoing from a very long time. We started with approach of neural networks, a term we got from human anatomy, neural networks. So when we discuss about humans, we know that neural network is a complex chain of neurons in humans' brain. Similarly, computer scientists, researchers are able to create an artificial neural network inside computer. So we have a human neural network, we have artificial neural network. So when we discuss human neural network, it has a structure to it. That we have neurons, each neuron passing information to another neuron, and that is going to be a huge chain. Similarly, these artificial neural networks are also going to perform same thing. That we will have a chain of artificial neurons, millions and millions of artificial neurons connected to each other, passing relevant information, filtering out irrelevant information. Now imagine when we are processing data. So imagine when we are processing data and data is really huge. This is going to make the neural network very complex. When this is going to make the neural network very complex, that causes the first issue of neural network: vanishing and exploding gradient problems. So here we discussed that we have this artificial intelligence. For artificial intelligence, two major use cases: natural language processing and computer vision. When we discuss either of these algorithms traditionally they were dependent on artificial neural network. We discussed how it is related to human network as well. Now, when we are using these artificial neural networks, they are going to be really complex, really huge. Processing data inside them, processing data inside the network, optimizing the network with right weights and biases is a task. When we try to do it, we are going to face some issues. The first one we face is vanishing and exploding gradient problem. That means these artificial neural networks that we are going to use, they look like these. We have an input layer. After the input layer, we can have n number of these hidden layers, and then we finally reach the output layer. Inside this input layer, the data is going to be passed. It is going to be processed sequentially from first layer to second layer to n number of hidden layers that we have. This can be 1 million, 10 million, 1 billion, and so on. So data being passed from the input layer, passed through these huge number of hidden layers, and then finally to the output layer. Similarly, inside each layer, we are going to have thousands or millions of neurons as well. These nodes, artificial neurons. So when we look at this thing is going to become really complex, where we have millions of layers, millions of nodes, and when we try to optimize it, that is when we try to make this model learn the weights and the biases. So when we try to make these models learn the weights and biases from a given data, be it for text or for computer vision, processing data in such a huge network, the information can be lost. Sometimes the model starts overestimating, that is, the learning that is being passed from these layers can be really huge. And similarly, in few cases, the learning from these hidden layers can be very minimum, even zero, making them redundant. So this issue was called vanishing and exploding gradient. That when the data is passed through this complex layer of millions of neurons, millions of hidden layers, the neural network is going to get confused. It is either going to give us very high values or low values, because of which we started facing issue of vanishing and exploding gradient. Second thing, we also discussed one thing here, that the data is always going to be passed sequentially. It will start from the input layer, it will go through each and every hidden layer, and then it will go to output layer. Now imagine thousands or millions of layers, data going from first point to last point. It is going to take too much time. And there is no parallel processing. It will always go inside that same sequential flow. So that made the training process really slow. So first we discussed vanishing and exploding gradient. The network is really complex. The machine is overestimating or underestimating the values. Similarly, the data is flowing in just one direction, starting from input to the output layer, which is making the training process also really slow. So which is making the training process really slow for us. So instead of neural networks, it was not just that. Okay, we started with artificial neural network and we did not try out other types of network. We tried to use recurrent neural network, that instead of having this standard structure, let's try to pass some information, keep some information to itself. Recurrent neural network. We also tried to add some gated architecture to it, where we get this long short-term memory and gated recurrent unit. But inside these specialized architecture as well, the natural language processing or computer vision tasks were not up to the mark. The machine was not able to remember the conversation at the start. Machine was not able to understand the important word in the sentence, the not important words in the sentence. It was not still able to understand the context for it. So for neural networks, we started with these artificial neural network. We also use these specialized networks. Even though they were specialized, they were not able to perform or give us the desired output. We try to retain some information in them and pass it so that it does not forget it, but still it was forgetting it. We tried to add some gates to it to retain the important information and to understand what is important and not, still it was not able to give us the required efficiency. So to overcome this issue, fairly recently, Google introduced transformer architecture. Google introduced transformers. So transformer introduced by Google in just 2017 revolutionized the landscape of NLP. Or we can say revolutionized the landscape of artificial intelligence by providing a all-powerful alternative to artificial neural networks. So we discussed that we were facing issues with artificial neural networks, even the special ones that we had like RNNs, LSTMs, and GRUs. To overcome this, Google fairly recently came up with transformer architecture just in 2017. Now, what made this better than these traditional model is, first one, self-attention mechanism. Remember when we discussed about artificial neural network or the specialized network, I mentioned that it was not able to understand the context behind the sentence. If we pass a sentence, the cat sat on the mat. If we pass this sentence, the traditional neural networks will not be able to understand what is the relationship between cat and sat. What is the relationship between sat and mat? Are these words, the, on, really important or not important? So these traditional neural networks fail to do that. To overcome this issue, inside the transformer architecture, Google introduced self-attention mechanism. So this self-attention mechanism captures a relationship between all tokens in a sequence regardless of the distance. So when we say tokens, in technology, these tokens are words. So this self-attention mechanism is able to capture relationship between words, between each words, even if they are really far away in a sentence. Like mentioned earlier, these artificial neural networks were not able to understand the context for a given sentence. Given a huge paragraph or a huge sentence, they would forget what was there in the beginning while generating the last end text. To overcome this issue, we got self-attention mechanism. This self-attention mechanism in a way tries to capture long-term dependencies, also what are the important words and the context for the sentence. We also discussed the second thing, the slow and too heavy network, to understand the context of it. So to overcome this issue, so first we discussed self-attention mechanism to overcome the issue between understanding the context. Now we also have an issue for large processing time, that the training time for artificial neural network is too huge. How can we cut down on that? So to overcome that, instead of having one standard network, Google came up with encoder-decoder structure. This encoder-decoder structure is going to mark the start of the sentence or end of the sentence. That is, when a sentence is given to the machine will have a marking that will inform the machine where is the starting point and where is the ending point. Similarly, these encoders and decoders, they are going to work parallelly. Instead of going in a sequence, they are going to work parallelly for us. So when we discuss about transformer, how did they revolutionize the industry? By adding these three mechanisms inside the artificial neural network and coming up with a new network. How did Google revolutionize the network? How did Google revolutionize the NLP? By creating transformer architecture with these three mechanisms in place. That is self-attention, encoder-decoder, and parallelization. When we say self-attention, it is understanding the context behind the sentences. Encoder-decoder, we are informing the start of the sentence or end of the sentence to the machine. And when this is happening, it is happening in parallel processing. It is just not starting from the first sentence and going to the last one. It is performing parallelly for each and every token or word that we have in the sentence here. So let's look into the development of transformers. So they were originally developed for machine translation tasks. That a machine, a sensor is generating output. What is this output being generated? But when we look at this use case, the use case is similar to human language translation or human language generation. Hence, this application was extended to natural language generation as well. We can see few examples, few verdicts on transformer. Great performance in computer vision like VIT, image classification, semantic segmentation.